Hi, my name is Dr. Welcome to today's video about the James Webb Space Telescope and its contribution to the science of exoplanets. This is a nice artist concept of the James Webb Space Telescope. You can see at the top the gold-plated beryllium mirrors. Beryllium was chosen as a material because it has a very good thermal properties, and gold is a very good reflector for infrared light. At the bottom you can see the multi-layer sun shield, which is made of Kapton. This sun shield is essential for the James Webb Space Telescope to work. This is a nice artist image of the red dwarf star AU Microscopii at a distance of 32 light years. This is called M star. It has a mass of 60% of the Sun. It is a very young star at an age of just 22 million years, and it has flaring activity. This is an animation of the debris disk of AU Microscopii from years 2010 to 2014. This consists of pictures from the Hubble Space Telescope and the Very Large Telescope, and it shows the ripple-like dust features of this system. And you can see this is still a planetary system in the making that is not completed yet. This is an artist's impression of the planet AU Microscopii B. This system contains at least 3 planets. This planet B has a mass of 18% of Jupiter. Its orbital period is 8.5 days, and you can see in this picture hiccups because the planet loses hydrogen due to photoionization by the stellar phase of the nearby star. This James Webb Space Telescope near-infrared camera image of the big debris disk of AU Microscopii has a radius of over 200 AU. 1 AU is a sun distance of 150 million kilometers. We can see the disk edge on, and the James Webb Space Telescope was able to find out that the gas-to-dust mass ratio is 6:1, which means this disk is gas poor. Typical disks have a much higher gas ratio. This is another artist's concept of a terrestrial planet. It's a hypothetical moon. 2 of the planets were found by the TESS mission. That's a all-sky survey mission with the transit method. And it could be that this system contains 4 planets. This is another artist's concept of a yellow dwarf star, also called G star, like our Sun. That's a WASP 96. It's a sun-like star at a distance of 1150 light years. It has 1.1 times the mass of the Sun. Its age is 9.4 plus minus 2.8 billion years. So it's very likely much more older than the Sun, which also means it has a lower metallicity. Metallicity is the percentage of elements other than helium and hydrogen. This is an image of the nearby planet WASP 96b. It is a hot Jupiter with about half the size of Jupiter, half the mass of Jupiter. It is very close to its star at just 0.05 AU. That's why it's so hot. The surface temperature is about 1000 degrees Celsius. And the current theory for these hot Jupiters is that they were formed further outside and then migrated inwards into the inner region of this system. This is a James Webb Space Telescope infrared image of the planet WASP 96b. You have to make 2 spectra. You make one spectrum when it's just in front of the star, and you make a second spectrum when the planet is behind the star. Then you can make the difference, and you can find which of the peaks are caused by the planet, by the atmosphere of the planet. And the James Webb Space Telescope showed that this planet contains water in the atmosphere. This is another very interesting system. That's the TRAPPIST-1 system. Its star is a cool M star, another red dwarf. But this one is on the lower end of the mass range. It's just 9% of the Sun's mass. Its size is 12% of the Sun's size. It is located at a distance of 40 light years. And what's special about this very lightweight stars is that they shine for a very long time because they have a very small fusion core. This star will shine for 10 trillion years. This animation of the 21 days of the measurements with the Spitzer telescope. You can see the peaks of the different planets. This system is edge on from our point of view. It contains 7 rocky planets, 3 of which are in the habitable zone of this system. This is an overview of the TRAPPIST-1 system. At the bottom you can see the 4 terrestrial planets of the solar system. At the top you can see the 7 about Earth-sized planets. This seems to be the most interesting candidate. It's planet E, that's right in the habitable zone, but also F and G are also very interesting. There are several factors that are important for a planet to be potentially a life planet. One is the distance from its star. Second is albedo, that's the reflectivity of the surface. And the third is the composition of the atmosphere, how much greenhouse gases are in the atmosphere. This is a picture of one of these planets, TRAPPIST-1c. It has 1.3 times the mass of Earth. It's too close to be a habitable planet with just 0.0158 AU. And the measurements with the James Webb Space Telescope showed that it does not contain a thick CO2 atmosphere like Venus. This planet is a different kind of planet. This is what could have happened to the planet of TRAPPIST-1c. That's atmosphere loss due to erosion by the stellar wind. And the question is, what about the planets that are in the habitable zone of the system? Have they also lost their atmosphere, or is there another mechanism that protects them? That is not answered yet. This is a nice artist's impression from the surface of our planet, how our TRAPPIST-1 would look like. It is very likely that all these planets are tidally locked. So the star would be at the same spot at the sky at all times. And this system TRAPPIST-1 is still a prime target for the James Webb Space Telescope. And that was today's video about the James Webb Space Telescope and the exoplanets science. Thank you for watching. Have a nice day. Bye bye.